Imagine pushing your spaceship to the absolute limit, faster and faster, until the stars outside stretch into streaks of light. But what if the universe itself began to warp around you, and your journey felt like no time had passed at all? That mind-bending thought experiment takes us into the realm of Albert Einstein's special theory of relativity. We're not just talking about going fast, we're talking about approaching the ultimate cosmic speed limit. But why can't anything with mass reach this speed? And what bizarre reality would unfold as we even get close? The speed of light in a vacuum, approximately 299,792,458 meters per second, is not just a high number, it's a universal constant, often called c. It's the fastest anything can travel in the universe. The fundamental reason you can't reach it is deeply tied to mass and energy. As an object with mass accelerates, its kinetic energy increases. According to Einstein, mass and energy are interchangeable. The faster you move, the more energy you have, and this energy effectively adds to your mass. So, as your spaceship pushes closer and closer to the speed of light, its mass would increase dramatically. To actually reach c, your ship would require an infinite amount of energy to accelerate its now infinite mass, an impossible feat. This isn't just a theoretical problem, it's a fundamental barrier woven into the fabric of spacetime. So since reaching light speed is impossible, what does it feel like, or rather, look like, for an intrepid traveler who gets very, very close? The effects are profound, manifesting in three key ways: time dilation, length contraction, and extreme visual distortion. First, time dilation. From your perspective inside the ship, everything would seem normal. You'd eat your space lunch, read your space book. But to someone watching you from Earth, your clock would slow down dramatically. Minutes for you could be hours, days, or even years for observers left behind. Imagine a journey to a star system 100 light-years away. For Earthbound observers, the round trip would take at least 200 years. For you, traveling at 99.99999% the speed of light, the journey might feel like just a few months or even weeks. The paradox is clear. From the outside, your journey would take decades or centuries. For you, it could be mere moments. Next, length contraction. As you approach light speed, distances in your direction of travel would appear to shorten to an outside observer. Your spaceship itself would appear compressed along its direction of motion. From your own viewpoint, the universe outside would appear to contract. A journey of millions of kilometers would seem to shrink before you, making your destination appear closer than it is. Finally, the visual effects would be truly alien. The light from stars ahead would blue shift, their light waves compressing into higher frequencies, potentially pushing them into the X-ray or gamma-ray spectrum and becoming invisible. Behind, they would redshift, stretching into longer, dimmer wavelengths, eventually disappearing into the radio spectrum. The entire visual field would warp, with stars appearing to converge into an incredibly bright, distorted point directly ahead of your ship, as if you were looking through a tunnel of light. This is where we must distinguish between approaching the speed of light, which presents these wild distortions, and reaching it, which is fundamentally impossible for anything with mass. But if, hypothetically, we could somehow achieve light speed, the experience would be even more extreme. For a traveler theoretically moving at sea, all sense of time would cease from an external viewpoint. Distances in the direction of travel would contract to zero. From your perspective, the entire universe in the direction you are moving would exist within a single, instantaneous point. The concept of travel itself would become meaningless, as you would experience your entire journey to any destination as having no duration at all. You would be everywhere and nowhere at once, timeless and without dimension. The speed of light isn't just a velocity, it's a fundamental barrier that defines our reality, a cosmic constant that governs time, space, and existence itself. What if the universe has other, faster ways to communicate that we simply cannot perceive?